Hi, hello, namaskara. Welcome back to Diksha Karnataka. I know it has been a long time since we have met again. So, just like the last year, once again the examination season has begun, and we have come up with a lot of helpful projects and videos for our students. So, once again, the previous year question paper discussion has come in. So, what we are going to do this time is, along with the video, the paper is available in the form of PDF in our description box. So, all of you can find that in our description box. So, whether you can attempt the paper and then see this video, or you can see this video and attempt the paper. So, have a good match of both of them. Alright, so this will be fruitful at the highest level. And first of all, talking about previous year paper, why do we do it? Mainly two reasons. That is, first, you will know exactly the pattern of the paper, how the paper is going to be, the difficulty level, the kind of questions that is coming from various chapters. And then second, more important one is you can gauge your level. So what level are you at? Are you matching the CET level? Are you below that? Are you above that? So all of this will be helped using the previous year paper. Alright, so let's check out the previous year paper questions one by one. This is basically from the 2023 paper that we are going to discuss, and we are going to discuss in parts. So part 1 will consist of question 1 to 30. So this particular video is focusing on question number 1 to 30. Alright, fine. So before that, let me give you another important announcement that we are going to start our Abhyas series just like last year. Last year is a huge hit. So we were able to conduct a few Abhyas papers all across Karnataka, and we had got really good responses, and we are going to begin it once again. So it's a free set of mock tests for everybody. There will be continuous and evaluation, continuous execution of papers. It will be held at a very regular interval, and we will discuss it also at a very regular interval. Alright, so I hope all of you will stay tuned with us, will subscribe to our channel for further details about all the programs that we are going to do, and also please like the video if you like it, and don't forget to put any comments in the comment section, whatever doubts you have or whatever videos you would like to view ahead, and everything that you would like to convey us. Alright, so let us quickly begin with the questions one by one. So the first question from the previous CET question paper, this is basically on the damped oscillation. So let me read out the question very quickly for you. A block of mass m is connected to a light spring of force constant k. The system is placed inside a damping medium of damping constant b. The instantaneous values of displacement, acceleration and energy of the block are x, a and e respectively. The initial amplitude of oscillation is a. So, and omega dash is the angular frequency of the oscillation. The incorrect expression related to the oscillation is, and these are the options that you can see on the screen. Now, first thing I would like to remind you is several topics have been deleted in with respect to the current or upcoming KCET examination. So KCET examinations included topics which are beyond the normal PU syllabus until last year. This year onwards, they are on par with the PUC syllabus. So the majority of the concepts which are really deleted in the PUC will not be asked in the KCET. Just like this damped oscillation, which is evidently deleted in the PUC portion, will not be asked. So it's an out of syllabus question, actually, look, purview as of now. But still, if we have to discuss about this, so the correct answer here, actually the correct answer here is D, which is the incorrect expression, which is D. Alright, rest all suits the expression very well. So we have the exponential result, we have the differential equation result, and we have the normal the kind of damped oscillation where we have k by m, which is the usual result, and we are negating the damping constant b square from this term. Alright, so A, B and C are correct. The incorrect expression here is option D. Alright, so I hope that is clear to all of you. Once again, let me remind you, if at all you have any confusions, you have any challenges, please post down in the comment section. We will be more than happy to view that and go through that once again. Alright, fine. So let us look at the next question, shall we? So next question, we have the speed of sound of an ideal gas. Alright, at a given temperature T is V, the RMS speed of gas molecules at that temperature is Vrms. So V is the normal temperature, Vrms is the RMS temperature. The velocities, ratio of velocity V Vrms for helium and oxygen gases are x and x dash respectively. What is x by x dash? This is a difficult question. Okay, when you are talking about difficulty, this is a difficult question. Alright, it's not easy or medium, it's actually difficult because we are talking about multiple concepts here. We are talking about V, VRMS. Now V generally is given as, you know, gamma RT, that is velocity, correct? So one second. Yeah. So we have the Pascal's correction formula, okay, divided by rho, and the VRMS, the root mean square value is equal to 3RT by rho, right? So this is the general formula for V and VRMS. So basically instead of rho you can write the that is RT, right? So we are talking about mass. So we needn't exactly get the density over here, we are talking about the mass, molar mass to be specific. Alright, so VRMS is okay. Now X for helium, okay, for helium X is given as V by VRMS, alright, and for oxygen it is X dash, which is equal to V by VRMS. Now I am not going to do it elaborately, just one hint which is the crux of this question with which you can solve is, you just need to know the gamma value, okay, rest everything will get cancelled. Now what is the gamma value for X? The gamma value for X, that is for helium, is a monoatomic gas. The gamma value is, it is 5 by 3, not 3 by 2, 3 by 2 is the other one, it is the 5 by 3, and for the oxygen, which is a diatomic value, the gamma value is 7 by 5, alright. So it is 5 by 3 and 7 by 5. So what you have to do is essentially substitute for both X and X dash, and when you cancel out, ultimately you will get the answer as option A, 5 by root 21. Alright, so option A is the correct answer over here. So this is how you do it. So VRMS and then X dash, okay. So it's lengthy process, you have to keep multiple things in mind and you cannot falter even at one step. Alright, so just the gamma value, if you substitute for each of this, okay, take the formula, just the gamma value, rest everything will get cancelled, RTM, 3 root and all will get cancelled. You just have to deal with this, alright, and ultimately you will get the answer as 5 by root 21. Alright, fine. So that was a difficult question, alright. So please keep such questions in mind, there can be difficult questions, so we are doing previous questions so that you have an understanding. Fine, so let us look at the next one. Yes, so a positively charged glass rod is brought near an uncharged metal sphere which is mounted on an insulated stand, okay. If the glass rod is removed, the net charge in the metal sphere is, now this is something a very straightforward question, it's a conceptual based question as well, it's not a very difficult question. So positively charged glass rod brought near an uncharged metal sphere which is mounted on an insulated stand. If the glass rod is removed, the net charge on the metal sphere is, yes, it is actually 0. So the net charge on the metal sphere is 0, okay. Now a very simple question and the answer is actually one word. Now I would request all of you to kind of comment what do you think is the answer of the reason for this question. It's just one word, okay, and let me give you a clue, it is starting with E as well, alright, fine. So metal sphere mounted on an insulated stand, alright. So what is the net charge on the metal sphere? Alright, fine. So I hope you will get it rightly. So let's make it an interaction kind of a thing, to one-on-one kind of. So you can also give your result in the comment section and we will see about it. Alright, fine. So let us see the next question. The next question is this. So it's a image based question. So you have an image. In the situation shown in the diagram, the magnitude of Q, okay, is very less than. So we have a small q over here, a small charge, and we have a larger charge for the dipole, alright, and R is very big compared to A. So A is the separation between charges and R is huge. The net force on the free charge minus Q and net torque on it is respectively. Yes, now this question is a mediocre question, like the difficulty is medium. It's not an easy question as well as it's not a difficult question as well. So you need to have a good sense of vectors. Now we are talking about force. First let's talk about force. Okay, net force and net torque. So force is given, it's a negative charge, positive charge. So this force is in this direction, and this force, negative repulsive force, it's in this direction. So the net force, as you know, let me use a different color so that you get it properly. This is the net force. Net force is in this direction, okay, and the net force, the correct answer over here is, so force is given by field into charge, okay. So field into charge, and this direction actually we can give the axis. So this is the positive x axis, this is the positive y axis, and perpendicular to the plane of this screen is z axis. So it is actually in the positive x axis. So we have a lot of options, two options with I, actually I, okay. So the correct answer over here is either B or C, because we have our answer in the positive x axis. It is not K, not K. Our force is not in the z axis, it is the positive x axis, okay. So it is either B or D. Now only thing is we have to confirm with the torque. Now how do you find the torque now? Now the torque formula is very simple, it is R cross F, okay. Now we know that our R is in this direction, this is the positive y direction, R j cap, okay, cross. Now what is our F value? F value is fixed, we already have it here. So it is 1 by 4 pi epsilon naught k something into PQ divided by R cube into I cap, okay. Now what is j cap cross I cap? Yes, this will give you the final answer. J cap cross I cap will give you finally the answer as negative k cap. J cross I cross j is k, j cross I is negative k, therefore we have arrived with our answer, which is option D, right. So this is a difficulty level, comes at a medium, so just observe. So you have to find the force first. Force is very intuitive, look at the direction, look at the vectors and take the resultant force which is in along the x axis, so that is fixed. So we have our force in the x axis, but torque as well, right. So how do you find torque? R cross F, R vector cross the F vector. R is along the j axis and F is along the x axis, so when you cross both of them you will get yes, okay. So this is the final answer. Once again, I really love all of you to give your own insights in the comment section. How do you see this question as? Do you feel this is easy or do you feel this is difficult? Okay, let's have this exercise as well. So medium level questions, let me see how many of you feel it is easy or difficult. Alright, so if you got this by on your own before I cracked it, very good. So you are very fast, so you have to see this timing as well, right. So let's slowly pick up our speed for the questions, because we need to look at that aspect as well. So the pressure of an ideal gas at constant volume is proportional. So it's a very simple straightforward question. Pressure and at a constant volume it is proportional to. So you have to look at the microscopic macroscopic relation of pressure, alright, in the beginning of the kinetic theory of gases. So there is a direct formula that the pressure actually is equal to 2 by 3 into E. Pressure per unit volume that I am talking about. Pressure at a constant unit, pressure per unit volume is actually 2/3 of the kinetic energy, right. That means the pressure at a constant volume is actually proportional to the average kinetic energy of the molecules, okay, average kinetic energy of the molecules. So it is not the potential energy, kinetic energy, because we are talking about kinetic theory, like the movement of the molecules, right. So it is B, it is neither force, it is not total energy of the gas, no, it is not the potential energy of the molecules as well, it is kinetic energy of the molecules. 3 by 2 kBT, that relation you would have seen, right. Yeah, so all of them are interrelated to each other, fine. It's a very simple straightforward question. I hope you wouldn't have any much doubt on this. Yes, now this is a slightly tricky question, so understand this properly. Electric field at a distance r from an infinitely long uniform charged straight conductor, like you have an infinitely long straight conductor at some r, it is E1, okay. Another uniformly charged conductor having the same linear charge density, okay, linear charge density is lambda, another one lambda is bent into a semicircle. So another one, it is bent into a semicircle whose radius is once again r, it is E2 at the center again the same lambda. Alright, so what is the relation between E1 and E2? Now this is a very straightforward thing. E1 for a straight conductor, you all know, lambda by 2 pi r. Okay, nothing confusing here, right? So it's pretty straightforward. But for this, how do you find it? Now we need to do a small mathematical process over here, if you know. So you have to take a small element, okay, small element of some arc length. Arc length will be, say, if you say this opening is d theta, so this is r d theta, okay, and we get a small electric field dE2, which is given as lambda r d theta divided by 4 pi epsilon naught r square. Okay, so the regulation formula for electric field with linear charge density lambda into length, which will give you the charge, divided by 4 pi epsilon naught r square. So all of you would understand this, how I did this and how I got this. Now the only thing is you have to integrate. If you want E2, you have to integrate it from negative pi by 2 to positive pi by 2. Okay, you have to integrate it negative pi by 2 to positive pi by 2, and the same thing, okay, apply the same one here, lambda r d theta divided by 4 pi epsilon naught r square. So when you do this, you will ultimately end up once again E2 is equal to lambda divided by 2 pi r. Okay, so of course there is epsilon naught, not to forget that. Okay, so E1 and E2 seems to be the same at both the cases. So the correct answer is option C. E1 and E2 are the same. Alright, that means for an infinitely long straight conductor, a point at a distance r from the conductor, I mean the object which is holding the charge, and for a semicircle of radius r at the center, both will have the same electric field. Okay, so this is a kind of a similar electric field condition. So yes, this is once again not an easy question, not a medium level question as well. If you really want to try it out and find, if you know the result early on, then okay fine, it's a memory based question. But if you have to really try it at that moment, it's not an easy question. You will have to be pretty thorough with your mathematical skills. Okay, mathematics is the language of physics, so you have to know very well for integration and the trigonometrical application, all that. Alright. And once again, if you have got this before me cracking this, if you already had an idea, very good. So please let me know in the comment section. Alright, fine. So let us look at the next question, shall we? Next question, 5 capacitors of value 1 microfarad are connected as shown in the figure. So it's a figure based question. Now you have to find what is the effective capacitor between A and B. Now this, let me redraw it, all of you would understand then. So you have a capacitor like this, okay, this is A, this is point B, so you have another capacitor like this, alright, and in between you have a 5th capacitor. So all are 1 microfarad, no doubt, okay, everywhere it is the same 1 microfarad. Now do you see the system, do you identify the system? Okay, if you do, let me know in the comment section. Yes, of course, it is the Wheatstone bridge, okay, no doubt it's the Wheatstone bridge. And is it balanced? Of course it is balanced, okay. So it's kind of Wheatstone bridge kind of a setup and it is balanced. So that means that the middle capacitor is pretty much ineffective in this condition. Okay, the middle capacitor is pretty much ineffective, it doesn't contribute. So the only capacitors are 1 and 1 in series, this both in series, then the entire combination in parallel. 1 and 1 in series, you know, it's half, 2 half in parallel, they add up. So the final answer over here in this situation, yes, it is obviously 1 microfarad. Okay, option A is the correct answer, bang on, there is no need of any confusion over here. So it's a simple Wheatstone bridge setup. So you have to check whether it is the balancing condition is really applicable over here. If it is applicable, then go ahead with the normal these two in series, these two series, then the entire thing in parallel and you get the answer. Okay, most of the time if they are identical, let alone be balancing beyond balancing, if they are identical, okay, if they are identical, definitely they are balancing. So the answer is directly, now this is a tip all of you can keep in mind. In Wheatstone bridge kind of a condition, if all the 4 are identical, it is balancing, and the ultimate answer is also the individual value, the final value is individual value. Okay, so it's a very simple thing. All of you can keep this with you. Even in case of resistors in Wheatstone bridge, you can keep the same tip in your mind. But in Wheatstone bridge kind of condition, if all of the components, resistors or capacitors, if they are the same, they end up, the equivalent resistance also end up to be the same. Alright, so that's the beauty of it. Alright, so I hope you really appreciate that. Alright, now this is a very easy, simple kind of a question, you can do it. Look at this problem. Yes, this is a kind of a mediocre, like medium level difficulty. It's not very easy, it's not very difficult also. If you know the concept, it's not very difficult. Just that you have to apply it. Now see, uniform electric field E exists. Okay, there is an electric field along horizontal direction. Electric potential at A is VA. Okay, so here it is VA, already it is given VA. Okay, so a small point charge is slowly taken from A to B, this path. Now the path is not at all an issue. Why? Because it's a conservative force. Okay, so being conservative force, the work done is independent of the path. Please keep that in mind. So path is just to trick you, so don't fall for it. You just need the effective distance, which is x already given. Okay, now the potential energy of the charge when it is at point B. Now what is the potential energy at B? This is the question. Okay, what is the potential energy at B? Now first of all, you already have a potential over here and you already had a potential energy. There was already a potential energy. So potential energy is actually charge into potential. So you already had a potential energy Q into VA. Alright, now you are moving it along the electric field, not against. Please keep it in mind. You are moving along the electric field. Okay, so your energy is only building up. So now what happens is that there is an extra energy, there is an extra work done in moving by the distance x, so which is given as plus extra plus charge into electric field into x, force into displacement. Force is q into E, displacement x. So the total, if you take q as a common, the total, the potential energy from moving it from A to B is actually given as VA plus E into x. Alright, so this is the potential energy when it is moved from A to B. So it already had a potential energy Q into VA, and then since it is moving in the direction, so what happens is that it is building more and you will get an extra this thing, that is Q into E into x. Alright, so the correct answer is option E. So it's very simple, the solution is very small. So it's not a very easy, you cannot get it as directly as possible, and it's not very difficult also. Of course, conceptual knowledge is required. If you know the concept, yes, you can crack it, but for an average person, slightly you have to think and you have to apply. Okay, confusion is possible because the directional comes into play, so you have to be very careful. Now let us look at the next one. A parallel plate capacitor of capacitance C1 with a dielectric slab in between its plates is connected to a battery. If the potential difference V1 across its plates, when the dielectric slab is removed, keeping the capacitor connected to the battery. Now it's a very serious case. Why? I'll let you know. Keeping the capacitor connected to the battery. So battery is not removed. The new capacitance and the potential difference are C1 and C2 and V2 respectively. Then, so what happens before, without removing the dielectric and after removing the dielectric? Now one thing is that always, please keep it in mind, look for this condition. If the battery is still connected, Kirchhoff's voltage rule, the net potential or whatever the net potential energy that the system, the circuit has, will remain constant. The algebraic sum is 0, that's what it means, right? Kirchhoff's voltage rule. Same applies over here. So the net, whatever the battery gives, that will remain in the system as it is. So the battery is giving to the capacitor is charged, it is having a voltage, so that goes nowhere because the battery is still giving it, battery is still connected. So you cannot, the capacitor cannot have its voltage being increased or decreased because battery is still connected, battery is still giving 5 volt, 6 volt, 9 volt, capacitor cannot have 1 volt, 2 volt, no, it will have how much ever it had before, even later. So the first and foremost thing is, when the battery is not removed, the capacitance voltage, potential difference will not change. So the first potential you can fix it with option B or D. The potential will not change. alright, with or without the removal of dielectric. Okay, yes. So now the potential doesn't change, V1 is equal to V2 no matter, because the battery is connected. So please keep that in mind. Important tip, the battery is still connected. It's not an isolated capacitor. Isolated capacitor, the things will be different. The capacitor is not isolated, it's still having a energy source, it's connected to a battery. In that case, potential will remain same, disregarding the dielectric. Now, initially there was a dielectric, later there is no dielectric. What does this dielectric do? The basic purpose of dielectric is to increase the capacitance. So when there is a presence of a dielectric, the capacitance will be more. When there is no dielectric, the capacitance will be less. So you all have seen like C is equal to K into epsilon naught A by D and all. So C is directly proportional to dielectric constant. When there is a dielectric, capacitance is more. When there is no, it is less. So the correct answer over here is option B. So both the potential is same and capacitance 1 will be greater than 2. This is a very simple thing, but this point is very important to be noted. Please make a note. If it is not an isolated capacitor, it's connected to a battery, as long as it is connected to a battery, a fixed battery without changing the EMF of the battery, the potential of the capacitance will remain same. Alright, so I hope you found this very important. Alright, this is actually an easy question, but please keep this point in mind. Alright, let's see another question. Yes, a cubical Gaussian surface has side length of A, 10 centimeter. Electric field lines are parallel to the x-axis, it is going in the positive x-axis. And the magnitudes of the electric field on ABCD, this side, okay, ABCD side, this is how much? 6 kilonewton per coulomb, and on the other side it is 9 kilonewton per coulomb. Okay, what is the total charge enclosed by the cube? Okay, so the charge enclosed by a particular closed Gaussian surface depends on the flux. Now how do you find the flux? First of all, we have two phases and both the phases are subjected to two different electric field. Now we have to find the net flux, because as the electric field varies, the flux also varies, right? So the flux is different, the flux coming out is different, flux coming in is different. So the net flux actually is the flux going out minus flux coming in. So which is very simple, the flux going out is 9 kilo, so I will keep it separate, into area A square, okay, which is 10 square, we will see later, into 6 into area A square, and kilo is there, let us not forget kilo, okay. So this is approximately 3 into A square, which is 10 square is 100 centimeter square, which is 0.01 meter square. So which is approximately 30 Web flux, which is electric field into area, so Newton per coulomb into meter square, okay. So that is the unit. Now what you want is, yes, charge enclosed. So according to Gauss law, flux is equal to Q by epsilon naught, okay. So the charge is equal to flux into epsilon naught. So ultimately when you multiply this with epsilon as 9 into 10, so you will get 0.27 nanocoulomb, 0.27 nanocoulomb as the correct answer. Alright, so this again is an easy question. Somewhere you can place it between easy and medium, because I personally prefer it to keep it an easy question, because it's a very generic result of finding the net flux and later finding the charge. So you would have practiced a lot. I am really confident that most of you would know this concept as well as this concept. So ultimately if you find the net flux, it's easy to find the charge. Alright, fine. So you let me know how did you feel this question, whether it was kind of easy or difficult, medium. Okay, it's definitely not difficult, okay. I wouldn't ever put this in a difficult category. It's either easy or medium, please let me know that. Alright, now the 11th question. 4 bands of a color coded resistor are in the are of the colors grey, red, gold, and the value of the resistor is, once again, so this time the CET will be on par with the PU syllabus. So the color codes is also taken off of the carbon resistor, so you needn't actually focus on the color codes. So as of now it's how it is. So and also we all know that mnemonic of BB Roy had a good wife and all that, BBR, that thing, you know. So even if you keep that in mind, you can easily crack this to be somewhere around 8.2. so it is, gray is 8, red and gold is 0, so it is 82 into, right, I think that's yes, so it is 8.2 into 10 to the power minus 5. Alright, so it is comes around C, fine, so that's okay. This once again, this question needn't focus more because this concept might not come mostly, okay, because according to the new syllabus what has been generated by the CET, very less chance, so it's okay. This color combination question is there, another one repeating. Now this is a very interesting question, very easy question, okay, just if you think and if you apply, if you think very straight, you will get this absolutely right. Wire of resistance R is connected across a cell of EMF E, okay, EMF epsilon, and internal resistance R. The current through the circuit is I. Time t, the work done by the battery to establish the current I is. So work done, so work energy relation. Alright, so what is the work energy relationship? Say that the work done in any condition is actually the difference in the energy. Okay, so whenever there is a difference in the energy, either increase or decrease, that difference is actually the work done. And the work done by the battery to establish the current I. Okay, so there is now two conflicting points, not conflicting, that there is points of confusion. Battery is doing the work to generate a current I. Battery is doing the work to generate a current I. What is the work done? Now energy is the point, okay, if you know the energy you will know the answer, and of course absolutely the answer here is actually I square RT. Okay, now lot of you can have question that okay, E square T by R also looks similar, okayish, dimensionally it also gives the same work done and it must be okay somewhat closer to the answer, but yes, this also I leave to you to think a little bit. Okay, I'll stress upon this, the work done by the battery to establish a current I. Okay, to establish a current I. So work done is actually difference in the energy. So what is the energy before there was I, a current I, and what is the energy later? Okay, so if you understand this, you will get why I square RT is the right answer and not exactly epsilon naught T, epsilon square T by R. So I really request you also to put your ideas further into this and let me know what you think about this question in the comment section. Alright, fine. So let us look at another question, 13th question. For a given electric current, the drift velocity of the conduction electrons in the copper wire is Vd and their mobility is mu. When the current is increased at a constant temperature, what is the correct answer? So what do you think will happen here? Either Vd remains the same, mu increases, Vd remains the same, mu decreases, Vd decreases, mu remains the same, Vd increases, mu remains the same. Now this again is a very straightforward question with a very straightforward answer. You just need to know the relationship, individual drift velocity mobility relationship. Mobility and current, what do you think is the relation? Mobility is defined as drift velocity per unit electric field. It is actually independent of current. Mobility is actually independent of current, therefore the mobility remains same. To be precise, the mobility remains same. There is no change in the mobility because of any change in the current. But drift velocity is not as such. Drift velocity is directly dependent on current, okay, or vice versa, current is directly dependent on drift velocity. So if there is a variation in the current, that implies there is a variation in the drift velocity, that too linearly. Therefore if they say that the current increases, obviously drift velocity must also increase, therefore the answer is D. Very straightforward, you just have to keep in mind the relations. If you know the relation properly of drift velocity, electric field and mobility and all that, if your understanding is pretty much to the point, you can easily score this, a very easily scoreable question. Alright, now again another question. So 10 identical cells, they are connected in series, each of EMF 2 volt. Okay, so there are 10 like this, so 2, 2, 2 and goes on, and you see are connected in series with 2 cells wrongly connected. So somewhere in between or at the end, let me draw it at the end, there are 2 cells connected wrongly, they are connected opposite. Okay, okay, 1 2 3 4 5 6 7 8 9 10. Okay, 7 8 9 10. So two are connected like this. Whenever you have two cells connected like this, what we will do is, like, they will try to negate another battery somewhere at the same level of their EMF. So since all are at the same level of EMF, this will negate this, this will negate this. So on the net, when you see the net battery, combination of cells is called a battery. When you see the net battery, two wrongly connected cells are negating two other cells. So finally, you know, 4 cells are giving no result. So in 10 cells, only 6 are giving result, 4 are not giving result. So when you see the net EMF is only 6 times, each has 2 volt, which is 12 volt. Ideally 10 into 2 should give 20, but 4 are killing themselves, okay, because of 2 are again gone. So total 4 are dead, 4 cells are not giving any result. But one thing that you have to keep in mind is internal resistance is 1 ohm. Now nothing will happen to internal resistance. That is very, very important point. Internal resistance will remain as it is. Nothing will happen to internal resistance. Just because the cells are oppositely connected, resistance doesn't mind, no, when however you are connected, resistance will be resistance. So there are 10 resistance. So total internal resistance, equivalent internal resistance, 10 into 1, 10 ohms, and external resistance is 10 ohms. It is given, there is an external resistance of 10 ohms. The resistance of 10 ohm is connected to the combination. What is the current through the resistor? Very simple. Now you have current is equal to EMF divided by R plus R. Very simple. So you have EMF as 12, you have a total has 10 plus 2, 20. So when you do it, ultimately you will get the answer as option C, 0.6. 12 by 20, it is 0.6. Alright, a very simple solution. Okay. Alright. So you just have to keep this in mind when what will happen when the cells are connected wrongly. Yes, definitely I would place this question as an easy question, definitely not medium, not difficult. This is a very simple point. Whenever the cell is wrongly connected, it will try to negate those many cells, or at least to that level of cell. Means when you are finding the net EMF, you have to negate those cells which are connected wrongly. So you have 2 plus 2 plus 2 plus 2, 8 2's will be there, and 2 minus 2, 8 plus 2 plus 2 plus 2 plus 2, 2 8 minus 2 minus 2. So those will cancel, other 2 plus 2's. Alright, so that's how you understand. Just if you have that idea, remaining everything is pretty straightforward. Alright, and you will ultimately get at this answer. Alright, so let us look at the 15th question. So we are midway through our discussion. So the 15th question is like this. Definitely this is infinite ladder. So we have, and this also the chances of such questions are less because the PU syllabus has already taken up combination of resistors. So ladder is an extension of combination of resistor ladder systems. So how to solve the ladder system? Let me just give you a very brief, because I am not sure how much this question can repeat in the 2024 KCET, but still the idea is here to first of all identify the repeating pattern. So where is the pattern repeating from? The pattern is repeating from this point. So this pattern is repeating rightwards. So you can redraw this diagram like this. So you have 2 ohms, 2 ohms, 2 ohms, and since it is a infinite series, this combination is almost equal to the total combination. The total combination is R equivalent. This is also almost equal to R equivalent because it's an infinite series. It's so huge that it's almost equal to the total. Just these 3 resistors would not make much of a difference, like that kind of an assumption. Okay, so this is R equivalent. These 2 are in parallel, these 2 are in series. Now when you take the entire one, okay, so these 2 are in parallel. So parallel you have 2 into R equivalent divided by 2 plus R equivalent, and other 2 are in series, plus 2 plus 2. Okay, so we have this entire system. Now this is equal to R equivalent. This is equal to R equivalent. Alright, so you can cancel the R equivalent somewhere, they will get cancelled, and you can solve for R equivalent. Ultimately you will get the answer as somewhat like 5.5. okay, so you can check this and let me know. Okay, and once again let me remind you, this question need not repeat once again in KCET 2024, this kind of question, because PUC has neglected this. Okay, so let's see whether we will commit, we will have to commit to such questions or not. Alright, so let's see the next question. Question number 16. A charged particle is subjected to an acceleration in a cyclotron as shown. A charged particle undergoes increase in its speed, so and so option. Once again, let me remind you students, the PU portion has been, they have got rid of the cyclotron years back. So this year, since the CET is proclaiming to follow the PU syllabus, so chances of cyclotron questions repeating this year are less, but still let's just discuss. So the D shapes here are actually giving the electric field. Okay, magnetic field is elsewhere, it has produced separately and there is a perpendicular magnetic field. So this D is actually the D shape, it's like a big hollow cylinder, like a cake, hollow cake, inside there is nothing metallic. When you cut it into half, you will get two D's, okay, inside it's hollow and there is an electric field. So when will there be an increase in its speed, when will it get accelerated? So in the particular diagram, where will the rotating or like spiraling electron or charged particle increase its speed? Inside D2, inside D1, inside D1, D2 and the gaps, only in the gap. Now you see inside the D's, inside the metallic hollows, the D hollow, electric field is constant, and there under the subjection of constant electric field, the velocity will be pretty much the same inside the D's. Only place where it get accelerated, the exam increases, the other D pulls it more towards itself, that is where the velocity increases, that is in the gap. So the correct answer over here is only in the gaps, okay, only in the gaps between D1 and D2, not inside at all, okay, not at all inside the D's, it happens only between the gap. And once again, this, since this question or this topic is under scrutiny whether to be included in the test or not, mostly not, so we needn't imply much of a focus on this. Alright, let's see the next question. Once again, this is a similar kind of a question, that topic which is most likely to be not repeated in this case set, that is the carbon resistance coloration. So 4.7 kilo, 4.7 kilo means 10 to the power 3. You can also write it as the standard form where you see the carbon resistance. Okay, so what is the power of the 2? That is the third band. The color of the third band is the power of 10. So power of 10 is 2, therefore BB Roy, red. Okay, 0, 1, 2. So 2 corresponds to color red. So this is the correct answer. Once again, this topic is again under scrutiny, so we're not sure how much will be shown in the test. Now look at this question, question 18. So all these questions are very straightforward. This question is also very straightforward. You just have to look for what you need, okay, only see what you want to see, don't be confused with the extra information. For example, a moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. It is already converted, okay, first of all keep that in mind. The galvanometer resistance is 90 and the shunt resistance is 10. You think this is of great value, these points. Think again, read the question. If there are 50 divisions on the galvanometer on either side, so total 50-50, total number of divisions are 100. Okay, so there are 100 divisions for your ammeter, galvanometer converted into ammeter, there are 100 divisions. The current sensitivity is, what is the current sensitivity formula? How do you write current sensitivity formula? Theta divided by I. Okay, deflection per unit current, that's current sensitivity, right? So you can just identify this as current sensitivity. So the current sensitivity phi by I, so theta by I. So how many divisions are there total? So when you consider galvanometer, you only see one side, but when you consider the ammeter, you see entire 50-50 across both the sides. We have 100 divisions on both the sides. Now the total current, so how much is your converted ammeter has total current? 5 milliampere, 10 to the power minus 3. So the correct answer is 1 by 5, that is 2 into 10 to the power 4 divisions per ampere. Option C is the correct answer over here. Alright, 2 into 10 to the power 4 divisions per ampere. Okay, yes, it's not ampere per division, it's divisions per ampere. Current sensitivity is what you have to actually focus on. Alright, yes, so number of divisions per unit current. Alright, yes, so that is one. This is very simple, direct, straightforward problem. Alright, now look at the next question. 19th question. A positively charged particle of mass m is passed through a velocity selector. It moves horizontally rightward without deviation along the line 2mv by qb with a speed v. The electric field is vertically downwards and the magnetic field into the plane of the paper. So now the electric field is switched off at t is equal to 0. The angular momentum of the particle about origin at t is equal to pi m by qb is. Now this is a very controversial question last year also, because there was claims of options not matching the answer. Now this question as well, so since there wasn't any particular one particular solution and one particular source which is giving an answer, let's just understand how to do it. Okay, let's not worry about the options, let's just understand. So they are asking the angular momentum. So angular momentum is given as r cross p. Okay, r cross p. Now r is the position with respect to the of course what do you call that, is the origin. Okay, so r cross p is angular momentum r with respect to origin. So let's consider that as for time being 2 mv divided by qb. Okay, 2 mv divided by qb, and this, suppose say at a particular time t is equal to 0 and t is equal to qm by b. Now there are multiple factors and this is a very difficult question. It's not easy, it's not mediocre, it's a difficult question. You have to keep multiple things in mind. First of all, okay, these all have meanings, they are all very relatable. 2 mv by qb, the radius of any particle which undergoes, the radius is given as mv divided by qb. So this position is given as 2 mv divided by qb. All right, next, so you have that this relation is there. Next, now t is given as pi m by qb. Now this is also very relatable. Why? Because the time period of completion, one whole completion, when a charged particle undergoes a circular motion in the presence of a perpendicular magnetic field, is given as 2 pi m divided by qb. So they are really implying that, so after the electric field is switched off, the electron under the presence of only magnetic field will undergo a circular path, and at t is equal to q pi m by qb, that means half time period, it is exactly coming back. Okay, it is moving in this direction, actually now it is going back in the opposite direction. So it is going back in the opposite direction. So the this of course you can write it as in the j direction, r position in the j direction. Okay, with respect to the origin, if you see, it is upwards in the j direction wherever the particle is. Alright, and this is cross p, momentum. Okay, momentum is going in the negative x direction. Okay, so it is in the mv minus I cap. Okay, mv minus I cap. So 2 mv by qb j cap cross mv I cap. So j cap cross I cap, my negative I cap, you will get once again j cross I, that is negative k. So already there is a negative positive k, so it will come out of the paper, that is angular momentum coming out. That's all okay, but look at this thing, that when you multiply r and p, the position as well as the momentum. Okay, position as well as momentum, so the m values gets multiplied and there is an m square, okay, in the numerator. Okay, 2 being as it is, or maybe if there is some change in the charge, we don't know, okay, what is the actual issue, because the options are not matching with the actual solution. So we have either if it is negatively charged, because then it will come down, positively it will go up. Okay, so this is there. So see, this is actually it is here. Okay, then this distance is given as 2 mv by qb. All right, so all that is given, but we don't know. So it is going up, and at that position it is negative and all that. So there should be an m square. Then we will have an essential v square divided by qb. Okay, so since it is a velocity selector, okay, we also have another clue, that's a velocity selector. So you will have velocity selector v is equal to e by b, or also you can write as v is equal to e square by b square. Even then if you put it over here, okay, you will get something as 2m square E square by Q, B square into B cube. Okay, so that is okay, but what about the square? So that is what this was a lot, kind of controversial about, when you use the position vector and there is an m component, in the momentum there is an m component. So how does this come? So we still have to clear this. So suppose if you feel that you have got some idea of your own, or you have got a kind of a solution from your end, you can put in the comment section. Maybe we have not researched it well or whatever. Okay, so let's have there is a good scope of debate and kind of a discussion over here, so just let us know. All right, fine. So this is this question, how to solve it, a brief understanding of how to do it. Okay, so please let us know your comments also in the comment section about this question. All right, fine. Let us look at the next question. A Curie temperature of cobalt and iron are 1400 and 1000 respectively at temperature 1600 K. The ratio of their magnetic susceptibility is. So Curie temperature, once again PU has actually removed the Curie temperature part from the paramagnetic materials, this thing, and also in the ferromagnetic paramagnetic the Curie temperature concept has been deleted. So once again this particular concept under scrutiny, but still for that matter let's just look at how this concept works. So susceptibility basically is inversely proportional to the change in the temperature. Okay, so from the Curie temperature how much does it change? Fine. So now the actual point here is, what is the ratio of magnetism of cobalt and iron? So they are asking the what is the cobalt susceptibility and iron susceptibility. So basically it is inversely proportional, so when you apply it, it will go up. So you will have T minus a Tc of iron, okay, and then you have T minus Tc of cobalt. See, I just simplified this directly because it's inversely proportional, so it will go up, it will go the other way around, so cobalt will come down. And when you apply this, okay, 1600 minus for iron it is 1400, so you will get around 200, then 200 by 600, so you will get approximately 1 by 3 as the answer, option D. Okay, so 200 by 600 you will get 1 by 3. You can work it out yourself. Actually if you know the concept, it's very simple direct formula, but since this concept is under scrutiny, once again not sure how far this will be coming in the 2024 examination, mostly not. Alright, fine. Let us look at another question. The torque acting on a magnetic dipole placed in a uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. Very simple straightforward formula. We know that the torque experienced by a dipole in external magnetic field is, okay, it is m cross b, or you can also write it as mb sine theta if you want to actually talk about the magnitude, let alone the direction. So if the magnetic moment and the magnetic field is actually non-zero, so what should be the angle here so that the theta is equal to 0? So if torque is equal to 0, that means theta is equal to 0. The correct answer is option D. The correct answer is very simply option D. Alright, the angle between the dipole axis and the magnetic field. So dipole axis is essentially the dipole moment direction and this thing. Alright, fine. So this is also very simple straightforward question. Let's look at the next question. The horizontal component of Earth's magnetic field at a place is 3 × 10⁻⁵. This is the horizontal component BH, okay, is given already. Now if the dip at the place is 45 degree, what is the magnetic field? Now this is also very straightforward, B cos 45. Okay, so BH is 3 × 10⁻⁵, and cos 45 is 1 by √2. Cross multiply, you will get option B as the correct answer. 3 √2 into 10⁻⁵ as the correct answer. But once again the problem over here is PUC has taken back the Earth's magnetism topic along with the angle of declination and inclination. Inclination I am still not sure, but I don't think this is harmful knowing this concept because it's very straightforward, very easy. Angle of inclination, angle of dip. So how does it vary with the latitude, how does it vary with the position on Earth, where is it maximum, where is it minimum, all that is very good to learn and keep it with you because it's not much. Alright, So even though if this topic is under scrutiny or not, please have a go through this topic. It's very simple and it's a very scoreable topic as well. Look at the next one. A proton and alpha particle moving with the same velocity. Now, these are all very important. Okay, these are all ratio based questions. Same velocity, uniform magnetic field. Their velocities are perpendicular to the magnetic field. Of course, circular path. Ratio of the radii of their path is. Now, radii formula is given to you. Ratio questions is often dealt by proportionalities. Radius is given as mv divided by qb. We have seen this, right? Now, eliminate the constant terms in this formula according to the situation. In this situation, v is a constant, b is uniform, you can quit all that. So, your radius is proportional to mass and charge. That means that you want the radius of proton and alpha particle, you just have to simply take the mass and charge ratio, okay, in this particular directly and inversely proportional. So mass is directly proportional, mp by m alpha, charge is inversely proportional, q alpha by qp. So when you just do them once again, okay, so you will get the answer as, see, this is 4 times, alpha is 1 by 4, this is 2 times. So we will get 1:2 as the correct answer. The correct answer over here is B. Okay, it is 1:2. So proton is 1, alpha particle is 4 times the mass of proton, and alpha particle is twice as charged as proton. There are 2 protons. Okay, you have only 1 over here in proton. All right. So you will get the answer as 1:2. All right. So this, once again, if you know this formula for radius as well as other corresponding versions of it, you have the kinetic energy, momentum, mv can be replaced by momentum. So they can give a lot of varieties in this particular question. Please mark this as an important question. Okay, there are chances of this question, this type of questions repeating. They can give same momentum, same kinetic energy. So you need to know a lot of iterations of the same formula. Very, very important, very straightforward. If you know this formula, you can get it very easily, right? The metallic oxide of a length 1 meter held along east-west direction is allowed to fall down freely. Okay, metallic rod falling down with an acceleration. So given the horizontal component of Earth's magnetic field BH, the EMF induced, it's a motional EMF question, very, very simple. So you have the induced EMF is given as BL into V. Velocity is not given directly. So you can use the formula for a free fall, it is GT. Velocity is given as BL into velocity for a free fall is GT. Okay, so because initial velocity is 0 and according to first equation of motion, V is equal to U plus AT, U is 0, so it is GT. So you have B is equal to, you can substitute all the values, okay. So 3 into 10 to the power minus 5, you have G as 10, T is equal to 2, length is 1 meter, and ultimately you will end up at an answer option D, 6 into 10 to the power minus 4. Okay, 6 into 10 to the power minus 4. Yes, that is the correct answer. So you can easily get it right. 3 into 10 to the power 5. Okay, hold on. Yes, 3 into 10 to the power 5 minus 5 into 10 into 2. So this 10 will cancel 1 negative, it will become minus 4 and 6. Alright, very simple. Once again, very, very simple. Motional EMF is very, very easy. You just have to know what kind of variation is happening, whether it's a linear movement or it's a rotational motion. Okay, along with that you can easily calculate. Alright, very simple. Once again, motional EMF is very, very simple. Next, again similarly on the motional EMF we have another question, repetitive. That is, now you have a loop. So when loop is entering into a magnetic field, so how does the induced EMF look like graphically? Okay, now you have to have a very good sense of understanding about the induced EMF, Faraday's law and Lenz's law. Okay, Lenz's law says that the induced EMF, of course the EMF will be induced because it is moving, it is entering into a magnetic field. Lenz's law says that the induced EMF polarity will be such that it negates its own cause. Okay, it goes against its own cause. So suppose when there is a coil entering a magnetic field, the flux starts increasing. Obviously the flux starts increasing. When the flux is increasing, EMF is induced. Lenz's law now comes into place. The induced EMF will be such that it acts against the cause or the cause of itself, the EMF. When the flux increases, the EMF will be such that it will be in the opposite direction, it will have a negative, okay, both of them negative. So the possibility is B or C, it is neither A nor D. So as the flux increases, it will be on the negative side, EMF. Now as it exits, the flux decreases, now it is on the positive side, Lenz's law once again, it's on the positive side. Now but which one will you choose? Now what happens here is, yes, the flux is changing, but as the flux changes, if it is moving uniformly, okay, so if it is moving uniformly, the square loop enters the magnetic field at a constant speed. The speed is constant. As long as the speed is constant, it is increasing uniformly. Magnetic flux is increasing uniformly. When the magnetic flux increases uniformly, you have a fixed EMF. The EMF generated is fixed. It's not increasing EMF. The EMF is fixed. This is the conceptual clarity that you need to have. Therefore, when the EMF is fixed, it will be step boxes like this. It won't be an increase or decrease like this. Alright. So as long as it is moving at a constant speed, flux is increasing at a constant rate, so you will have a fixed EMF. Okay, when it is accelerating, of course this is possible, but it's not accelerating, it is moving at a uniform speed. So the correct answer is B, and you need to have this particular conceptual clarity. Alright, so all these tips which I have told in between are very, very important, please keep it in mind. Alright, let's look at the next question. The next question is, in a series LCR circuit at resonance, it's the biggest clue you can have, right? At resonance, the phase difference between the voltage and the current is, come on here. So we have talked about this. So you can have mathematical expression, mathematical solution to this, mathematical treatment where you take the phi value tan phi, XL minus XC by R, all that, where they both are equal, so phi phase angle is 0. So whenever the phase angle is 0, what happens is, whenever it is in resonance, basically that means that the phase difference is 0. It's a very simple, straightforward answer. Okay, so the answer is 0. So the resonance itself means that there is no phase difference. There is maximum, like both there the inherent frequencies are matching, and there is a maximum amplitude developed. So the phase actually is 0. Phase difference is 0. There is no difference in the phase. Alright, that is the correct answer. Fine. Next, an ideal transformer, that's once again a big clue. Ideal transformer has turns ratio 10. Turns ratio is secondary turns to primary turns 10. When the primary is connected to 220 volt and 50 hertz AC source, the power output. Once again, please learn how to ignore the unwanted input. So they are asking power output and they have given ideal transformer. Power output is always equal to the input power if it is an ideal transformer. That's all. You don't need the turns ratio, you don't need input voltage, frequency, nothing. So if it is an ideal transformer, the efficiency is equal to 1. That means that the input power is equal to the output power. Simple. Okay. So there will be a lot of other extra information given to confuse you, but stick on to your course, stick on to your strengths, and if you know the conceptual idea behind this, you can easily, very well get to the correct answer immediately. So ideal transformer says that the power output is equal to the power input. Simple. Alright, so you get a lot of easy questions. Please try to cash in on all of them. The current in a coil changes from 2 ampere to 5 ampere in 0.3 seconds. So there is change in current, there is change in time. The magnitude of EMF induced in the coil is 1 volt. The value of the self-inductance of the coil is very simple. Once again, EMF formula which is given by mod is equal to di by dt. So change in current per unit change in time, so that is 2 to 3, that is 3 amperes the change, the time is 0.3, and the EMF is given as 1 volt. So when you cross multiply, ultimately you will get L value as 100 millihenry. Okay, that is 0.1 Henry, that is 100 millihenry. Okay, 0.1 Henry is 100 millihenry. L is equal to 0.1 Henry, which is 100 millihenry. Once again, a very straightforward question, direct application of the formula, right? Next, the ratio of the magnitudes of electric field to the Magnetic field of an electromagnetic wave is in an order of, very simple here, once again, very straightforward formula, E by B for an electromagnetic wave. It is in the order of speed of light, or at least close to it, which is 10 to the power 8 meter per second. Obviously, it is option B. Straightforward question once again. Now we are coming to the last question of this particular session. Okay, this video contains only 30 questions, as I've told you. Last question is, for a point object, which of the following always produces virtual images? Plano convex lens. No, you know convex lens doesn't always produce virtual lens. Nope. Biconvex lens. Nope. None of the convex lenses always produces virtual image. Concave mirror also, we have seen all the ray diagrams. It only produces at one particular range of position. It produces virtual image. Otherwise, it's real. Only correct answer here is convex. Convex, yes, it always produces virtual images. Alright, so in the first 30 questions, as we have analyzed the last, towards the end of the 30th, as we are approaching 30th questions, a lot of the questions were very easy, very straightforward, to the point. Okay, so I hope you have got all this, and if at all you need any kind of further enhancement in the explanation or discussion, you want to kind of have a debate on any question, please feel free to put it up in the comment section. Please feel free, whatever you feel about our videos, whether it's good or bad, or if you can if we can improve from our side, anything it is, or if you need any information, please let us know in the comment section very diligently. All right, so coming to the end of the video, let me remind you once again, so the Lakshya crash course also is available for the KCET particular examination. So we are enabling you to crack KCET within 20 days. So yes, it's not a very easy task unless you cooperate with us. So if you given your entirety of your time and your effort with us, definitely we promise you that we'll help you, we'll guide you in the right direction to crack the KCET and get into one of the most prestigious institutes in Karnataka. So that's it from my end. I hope really you like the video. So please like the video. And lot of students who need this video and need this support, so please share this video to all of them, so that it will be a great help to all of them. And also don't forget to subscribe to our channel for further updates and all the analysis, paper discussion, everything that we are doing. All right, and that's it from my end, students. I hope you really are doing great, and I believe that we all will succeed together in this great journey. So until the next time we meet, bye bye, take care, see you.